All right, well, we have talked about conic sections, and we did a lab, some of you did a lab, where you found out that this formula can generate any conic section, circle, ellipse, hyperbola, parabola, even a rectangular parabola. The reason you can do it is because these constants, A, B, C, D, E, and F, can be different things, including 0, to yield different things. So let's say I wanted to make a circle. Which of these constants am I going to need? A, B, C, D, E, or F? What am I going to need for a circle, for sure? You're going to have A, because you're going to need an x squared. What else are you going to need? C, you're going to need a y squared. And we'll come back to this one. We're going to need one more. What else are we going to need? You're going to have some constant at the end. And so this will make a circle. It'll also make a what? Ellipse. Why will it make an ellipse, Patrick? A and C are different. If A and C are the same, it's a circle. A and C are different, it's an ellipse. And then with an ellipse, you can also, well, and a circle, you can have the D and the E. Now, what do you need to make a hyperbola? Well, for a circle, we needed A, C, and F. For an ellipse, we needed A, C, and F. What do you need for a hyperbola? A, C, and F again. Except, what's C going to be this time? Negative. Or you could have C positive and A negative reversed. But yeah, for a hyperbola, you need it. So that's kind of interesting. The only one that's different is the parabola. For the parabola, you only need either A or C. Either one for the parabola. But anyway, what they're showing here with these examples is you can look at how they can use different numbers into ABC to get that. What we're most interested in, though, is this guy, because we've been ignoring XY pretty much this whole time. But all XY is going to do is to tilt one way or the other. But the question is, how do you deal with that? Well, the way you deal with it is you turn it into matrices, and you break that matrix down. Beat it down. So what we're going to do is, first of all, we're going to generate the conic section equation. And I know this is staring at you. I know it's doing it. But I want you to physically do this with me. Show the multiplication, just so you remember some of this matrices stuff. You're going to take X matrix is XY, A matrix is A, B, B, C. Now notice that B is a replicant. B is twice there. That's important for this, for generating the conic section. But everything else is fine. Eventually, we're going to run into this V equal to DE. But we have X equal to XY, A equal to AB, BC, and V equal to DE. Now, anybody remember what AT meant? Transpose. So normally XY looks like this. We're going to transpose it to XY, and we're going to multiply it by AB, BC. When I do that, we multiply rows by columns. Would you repeat that after me, please? Rows by columns. That was way too excited. Do it more boring. Ready? Rows by columns. So here's the row. Here's the column. When I multiply that out, I get XA plus YB. And then I'm going to shift this thing over. And I'm going to have another entry, which is going to be YB plus YC. Or, I'm sorry, XB plus YC. Thank you. Okay? So that's a new matrix. This is a rows by columns. It's a 1 by 2. This is a 2 by 2. What's this one? 1 by 2, correct. And we're going to multiply it by XY. So you have A to the T times A. We did that. Now we're going to multiply that by X. So what happens here is I take this times X plus this times Y, and so I get I'm going to just write it here, x squared a plus y squared b. Then I'm going to get plus x squared b plus y squared c. I want to make sure I did this right. Doesn't look like I did it right. Oh, I didn't do it right. Try it again. So I have xax, or x squared a, plus xyb, and then it's going to be plus x squared b. Let's see, wait a minute. Nope, nope. It is going to be, let's see, rows by column, plus, oh yeah, this one here is going to be xyb plus y squared c. There we go. Whew. All right, so here's your x squared a, here's your y squared c, and then how many of these xyb's do we have? 2. And that's because of that replicant b. That's why you get that. And there's the part that we've done so far. Once you have that, you do want to get these other ones to get the whole general conic section. And what they did is they took v, which is dE, they transposed it into dE, and they multiply it by x, xy. So do you see how they get dE plus EY? And then what's this f? Just threw it in there. So this is the matrix form for the conic section, and that's going to enable us to find the rotation. And the reason it helps us find the rotation is that this part we can analyze, and this is going to help us to get what we want. So they're just kind of showing you a step-by-step process here. I'm not sure how helpful it is, but you rewrite it in vector form, find the eigenvalues and corresponding eigenvectors. You use the normalized eigenvectors to find the rotation. And then we're going to use x equal px prime and x prime equal x prime y prime to find the equation. And then we'll be using this as a part of that. None of this makes any sense to you. Yeah, but watch this. Go to the next slide. I made a whole slide for this because it is so ridiculously important for this. And if you don't see this, none of it's going to make sense. So can everybody look up here and look at this anti-clockwise, counterclockwise. This is the rotation formula. If you can write it in this form and you know what theta is, you can figure out what that rotation counterclockwise is. I am going to, the book doesn't talk about this, but I've kind of figured it out with some help. Clockwise. We can do this the other way by going cosine theta, negative sine theta, sine theta, cosine theta. We just learned this at the very end. Would you write that down, please? The very end of last hour, we figured this out. So here's counterclockwise, here's clockwise. Just a quick highlight for this one, you're going to rotate this way. And then for the clockwise, you're going to rotate it that way. All right. Now, we're going to take an example. I'm going to do this one all the way through, and even though you can just read this right off, I do want to write on it. I want you to write on it with me so that you can kind of follow along, and then we'll go right into a class example. Using a suitable rotation, rewrite 5x squared plus 4xy plus 5y squared equals 21. So this is your standard form. We want to put it into a form we could graph. This is kind of interesting, actually. So the first thing they're going to do is they're going to write this into x of t a x equal 21 form. Okay? So first of all, how did they get x of t here? What did they do with that? Well, they just did x, y, and transpose it. That's no big deal. But the a is the tricky one. So for the a, I'm going to have you look here. Here's little a. Here's c. And so a is equal to, remember when I wrote it was a, b, b, c? Remember that? So I get a as 5. I get that. I get c as 5 in this example. They don't have to be the same. But what's b? 2, because this is 2b. Remember that the formula was ax squared plus 2a xy? Yeah, so that's, or 2b xy. So that's why this is a 2 and not a 4, and these are the same. You okay with that? And then back in time, we found that if you took, I'm going to write it this way now. If you took lambda I minus a and took the magnitude of that, set it equal to 0, you're going to be able to find the eigenvalues. So lambda I a. So what does that mean? Well, it's lambda times 1001 minus a. Was that 5225? Okay. So before we do this, I just wanted to show you what's going on. This is the same as the determinant of lambda 0, 0 lambda minus 5225 equals 0. So can we combine these two? Yeah. So this is just going to be lambda minus 5, 0 minus 2, 0 minus 2, lambda minus 5. And now we can take the determinant of that. And the determinant of that is lambda minus 5. Do you remember this from last summer? You did 1 times AD minus BC, so it'll be negative 2 equals 0. So this is going to be lambda squared minus 10 lambda plus 25 minus 4. They get lambda squared minus 10 lambda plus 21. Is that factorable? Cross my fingers, I hope it is. No, I don't want any quadratics. Can we just factor it? Say yes. Does it? 7 and 3, both negative. So that means my two eigenvalues are 3 and 7. Okay, so all that work was to find 3, 7, but that's not that hard. We get that pretty well. So that's what they did here. They found 3 and 7 are the eigenvalues. Then what they did is they started with lambda equal to 3 and just put a 3 into this formula. 3 minus 5 is negative 2, negative 2, negative 2. 3 minus 5 is negative 2, and so there you got it. What they're doing here is they're taking this matricy difference and then they're dot prodding it with x and setting it equal to 0. So what's happening here is you're going to get negative 2x minus 2y, rows by columns, equals 0. And you'll get it a second time. We don't need to write it. Can this simplify to x plus y equal to 0? Good. Caleb, clockwise or counterclockwise? Which do you want? You choose. Whew, that was a lot of pressure. If you did counterclockwise, you'd get it the way the book did it. Do you want to go against the book? It'll make it a little harder for me. You're going to go your own way? I like it. Oh, you want to go the way the book is? Oh, okay. Because, well, here's the thing. For this example, they do it counterclockwise, and then all the answers for the problems you do are in clockwise. So I don't know why they did that. They're just messing with me, I think. Let's do this. Let's do this. I like this idea. Let's see if we can go Caleb's way. Okay? Go Caleb's way. X plus y equals 0, so you're going to get -1 plus 1, or -1 plus 1. There's an infinite number of answers, but we're going to go the easy way. Okay? The easy way. The easiest numbers are 1 and -1. So we're going to put -1 and 1. And if we're doing it Caleb's way, it really should be 1, -1. Times t, it's parametric for I can do any number, an infinite number of answers. That's my x. Now, when you put the 7 in, up here, put a 7 in this time. 7 minus 5 is 2, -2, -2. 7 minus 5 is 2. Now you're going to have 2x minus 2y. Divide both sides by 2, including the 0. You get x minus y. Now the simplest numbers are going to be 1 and 1. But, you know, those other ones too. So now this one is going to be 1, 1t. Now you got to decide, do you want to do it the counterclockwise or the clockwise? I'm going to go with the counterclockwise, or clockwise, that Caleb said. Notice where the negative is, down here. You have to choose how you're going to lay these in so that you get either this way or that way. The book for this example did up here, counterclockwise. We're going to do it clockwise. I think you're going to like this answer. I hope. So what is 1 over the square root of 2? That's the magnitude of 1 squared plus 1 squared square root. So this thing is going to be 1, -1, 1, 1. And then we want this to be a length of 1. Right now, this is the length of square root of 2. So if we divide by the square root of 2, now you've got it so that it's going to be length 1. Now, this was cosine of theta, and this was negative sine theta. So, if you go down to here, this was cosine theta, and this is negative sine of theta, right? So what you can do is you can say the cosine of theta is equal to 1 over square root of 2, and the sine of theta is going to be equal to -1 over the square root of 2. Now, on the unit circle, you know it's one of these 4 spots, A, B, C, D, and I think if the cosine is positive and the sine is negative, it's going to be this one here, isn't it? Yeah. Then it's not going to be, my problem is, here's what I don't like, is that, yeah, I think you're right because the negative's already there, so sine of theta is 1 over square root of 2. But here's what my problem is that the rotation is pi over 4, which is the answer, but it's pi over 4 counterclockwise, right? Well, let's just go with that. It's pi over 4. We got pi over 4. Perfect. So the next thing that we're going to do is to get the equation. So this part is actually the easy part. You've got the x equal px prime. That's what x is. And so remember when I said that x of t times a times x was equal to 21? We had that. Now I'm going to replace x with px prime. And so what all that's going to do is x is p, x prime times p. P is a constant, so I can switch it. A, and then x is p x. Well, this is transposed, and this is p prime x prime equals 21. Now, this guy here has a name. That is, don't want that color. This is my diagonal orthogonal matrix, which we can replace with the two eigenvalues, 7, 0, 0, 3. And then you just multiply this by x prime, y prime, x prime, y prime, equal to 21. Stop. Would you write that down? Write that part down. We are almost done. We're almost done. Yes? Their magnitudes are the same? Oh. Good question. I think they're going to be the same because of the process we use to find the eigenvalues. The eigenvalues are going to ensure that, I think. I haven't run into it differently. Yeah?
How did you go from xt, ax, equals 21 to the next one?
To this one? Yeah. Great question. So what I know is that this PTAP, these are constants, P and T, and so what we're going to do is we're going to, there was something we did in linear algebra where we saw that this thing was equal to eigenvalue 1, 0, 0 eigenvalue. We want this. So we're substituting x to be p x prime. So we don't know what x prime is, but we have p x prime. And this p is going to help us in the long run. So what I did is I just said, okay, if you have x of t ax, replace it with x prime of t p and x prime of t x prime x p prime. And then these guys, I'm just replacing, I'm replacing this with this. And then this is replaced with that. Then all that you do is you take the transposition of x prime, y prime, and you're going to get rows by columns. X prime times 7 plus 0. And then it's going to be, the next one is going to be, let's see, 0 y prime times 3. And then we're going to multiply this by x prime, y prime, equal 21. X prime, 7 times x prime is x prime squared times 7 plus 3 times y prime squared equal 21. And if you divide by 21 like this, you're going to get x prime squared over 3 plus y prime squared over 7 equals 1. That is your equation. That's it. And then what we're going to do next is we're going to work on, just a second. We're going to work on problem 1A and B. That's your assignment for tomorrow.